You want a curveball? How about a slider? All right. So in this example, first thing we want to look at is, obviously, we can't algebraically simplify this in any regard. So let's go ahead and apply our direct substitution. When we apply direct substitution, we get e to the 0 minus 1 over sine of 2 times 0. Well, obviously, sine of 2 times 0 is just 0. Sine of 0, we look at the unit circle. That's going to be 0. E to the 0 is 1. 1 minus 1 is 0 over 0. So therefore, again, we have an indeterminate form. So therefore, we're going to want to take the derivative of the numerator and the denominator, in this case with respect to x. So taking the derivative of the numerator is just going to leave us with e to the x. And derivative of the denominator is going to be 2 cosine, be careful, of 2x. Right, doing a little chain rule, really cosine of 2x times 2, and then let's throw the 2 in the front. Yes? Follow? So therefore, when we can apply direct substitution here. So that's e to the 0 over 2 times cosine of 2 to the 0. And e to the 0 is going to equal 1 over 0. So that's cosine 0 is 1, so that's 1/2. 2. So 1/2. It's not that bad, right? I think there's maybe. So in this example, guys, if we want to evaluate the limit for basically when evaluating the limit here, we're just going to obviously apply direct substitution. And we see that the sine of 0 is going to be 0 over 0, which is our indeterminate form. So therefore, we can apply L'Hopital's rule, which means that we're basically going to take the derivative of the numerator with respect to x and derivative of the denominator. So when we do that, we get the derivative of sine of x is cosine of x over 1. And now we can apply direct substitution here. I'm not going to show the direct substitution, but cosine of 0 is going to equal 1 over 1, which is now equal to 1, because the cosine of 0 is 1. Right? Or, yeah. There you go. That's basically it. That's it. Done. Wow. That was a quick lesson. Sweet. 30 seconds. Saved. All right. But for this next one, we have an issue because this one's tangent, right? We don't have anything for tangent, correct? We don't have anything for tangent. However, we do realize that tangent is sine of x over cosine of x over x. Right? Remember tangent sine of x over cosine of x? So then I can think about this as a fraction divided by a fraction. And when I have fractions divided by fractions, I always like to multiply by the reciprocal. So now, by simplifying this, I have sine of x over x times cosine of x. Well, I can separate this. I can group these together because I want those to be grouped together. So that would look like sine of x over x times 1 over cosine of x. Well, as the limit, we know that this is going to, as the limit as x approaches 0, that's going to equal sine of x over x is going to equal 1. And then as 1 over cosine of 0, did I write that down correctly? Yeah, the cosine. And the cosine, if you remember the unit circle, at the angle 0, cosine is going to be 1. So 1 divided by 1 is 1 times 1, which equals 1. OK, so remember, guys, to transform your function. You remember. So remember, guys, when we had it just as tangent, we could follow along with this pattern. But now we change this to squared, and we have a little bit something different going on. Now we basically have sine squared of x over cosine squared of x over x. But again, what do we want? We want that sine of x, right? We want sine of x over x, or 1 minus cosine of x over x. So again, we're basically going to do the same thing. Let's rewrite this as sine squared of x times 1 over cosine of x, cosine squared of x over x. Now the problem is here, when we go ahead and separate this, we don't have anything for sine squared of x over x. So what we have to do is break this down one more time. So I'm going to rewrite the limit. Okay, and I'm going to say this is going to be sine of x times sine of x times. I could break apart the 1 minus cosine squared, but that's not really going to help us out. So let's leave it like that. Now, at least this way, we can say, OK, so let's group this together. We know that's going to go to 1. And if we plug a 0 in for cosine, cosine again at 0 is going to be 1. Square that is 1. 1 divided by 1 is 1. But if we plug 0 in for this, 0 into sine of x, so the sine of 0 is, again, knowing the unit circle, right? So cosine is 1. So sine is going to be 0. So it's 0 times 1, which we know is just going to equal 0. OK? But just make sure, guys, what we practiced last class period, make sure you guys can.
Okay, let's talk about the limit as theta goes to 0 of sine theta over theta. Yes, if we put 0 right here and right here, we end up with 0 over 0. So maybe let's just go ahead and do the L'Hopital's rule. Let's put down d theta, d theta. So we are showing work, and our teacher will be happy, right? So this is the limit as theta goes to 0. And then when you differentiate sine theta, we get cosine theta. And then when we differentiate theta, we just get 1. And then now we can just put a 0 right here. And in the end, we are saying this is just cosine of 0. Of course, we can work this out. This is just 1. That's it. Took us about like 37 seconds. That's it. And yeah. Okay, has this ever happened to you guys? You did this on the test, but in the end, you end up with a big X like that, and you end up with 0.0 marks for this question. If this has happened to you, leave a comment down below. And you might be wondering, like, what's so wrong with this? Yes, we do the L'Hopital's rule, and this is a 0 over 0 situation. Is it because I didn't show work? I forgot to put down this is a 0 over 0 situation at LH. Maybe I just forgot to show work. Okay, now here's the problem. The issue is that when you differentiate sine theta, yes, the answer is cosine theta, but how do you know that? Well, if you guys look back to the proof of the derivative of sine theta, in fact, you need to first know what the limit as theta goes to 0 of sine theta over theta is first, before you can talk about the derivative of sine theta. So, in other words, we cannot use derivative. We cannot use L'Hopital's rule to figure this limit out, because otherwise, this is what we call the circular reasoning. That's really bad.